So so we've got 3 blocks. They've all got a force of 10 newtons. The left one has got a force to the right of 10 newtons. The middle one's got a force to the left of 10 newtons. And the one on the right has got a force to the right and to the left, both of 10 newtons. They're all moving to the right at 5 meters per second. The one, I've mistyped there. The resultant force on the one on the left is 10 newtons to the right. And the forces are not balanced because there's no other force. So the object's going to accelerate, which means it's going to speed up. So forces cause acceleration, but they can also cause deceleration. And that's if the force is going the opposite direction to the speed, to the movement. Okay? And so it decelerates, it slows down. But if the forces are balanced or the resultant force is 0, then it stays at a constant speed. It doesn't accelerate. Yeah? Okay? So let's make sure that's clear. I mean, if it's not moving, then it stays not moving. But if it is moving, it stays moving at the same speed. Okay? So I'm going to just pause the video and then we'll add onto the video a little play with some simulation. So what we're going to do is we're going to apply a force to this filing cabinet, and we're going to have a look at what happens to the velocity. The velocity is basically the same as speed. It's not quite the same, but we're not going to learn about why it's not the same at the moment. But we can briefly see that we can have a negative velocity. You can't have a negative speed. But apart from that, it's basically the same as speed. So we're going to apply a force. The way you do that is you click on the man and then move to the right. But you have to press go first, by the looks of it. So do you want to have a go at that as well? I'll do it first, or you can do it first. I don't mind, but I'll show you on my screen. So you click on the man. Oh, let's try that again. Oh, okay, right, here we are. Click. There we go. I'm applying a force. And it shows what's happening to the speed underneath. Oh, is it not working? I'll just demonstrate it on here. Then basically I'll just demonstrate it here. Then I'll have a look. As I applied the force, the velocity increased, and it increased at a steady rate. So it was a constant acceleration, and you can actually work out this acceleration from the graph. But that's what a velocity graph would look like. That's what it would look like if it was accelerating. I'm just going to reset it though, and then I'll show you. I'll have a look at yours. So now I'm going to apply it. I'm going to do it with with a bigger force, and you can see the velocity increases at a faster rate. It's a steeper graph, right? It was a more gentle slope, and then it was a steeper graph. Okay, so larger force, larger acceleration. All right, and we can look at these velocity time graphs as well. But let's just stop that video there, and I'll put that in your whiteboard, and we will, and then you can share your screen.